Hello, good afternoon, everyone. My name is Vineet, and today I'll be conducting this session on designing a distributed cache.
All right, so step 2, identifying what services we need. Here, technically, there is only one, the cache server itself, at least from the client's perspective, right? Like client does not need to know what all different components that go on. Cache client, like again, that probably won't be a separate service. It will be a library that the client uses to talk to the cache service. So what this means is it's a depth-oriented problem. Again, not that the interviewer cares, but from your own setting your own expectations, you should expect the interviewer to ask a lot of questions about that one service, because that's the only thing that you're discussing, as opposed to, let's say, breadth-oriented problems. If you have multiple different services, then you can talk about many different things, and the complications are a little different than what you would have in your in just the depth-oriented problem where you have one or two services. Step 3, drawing the logical diagram. If you want to start simple and start small, again, can't get any easier than this. And this is not the diagram of the cache server itself. It is how the cache is being used. And as also we saw in different strategies, like you could either go through the cache, the app can go through cache to database, or can be on the slide. It's okay to start like this, but then as you're tackling individual requirements, then you could kind of expand on this box to say that, okay, how that will look in the real system. This cannot be your final diagram, because obviously, like, this does not explain anything distributed about the cache. But it's okay to start small, saying that, okay, we only have these components. Let's dive into a component and see what all things we need to consider over there that will satisfy our functional and non-functional requirements. Ashok is asking, can you please explain the difference between a service and a library? Service is a completely separate process, which is running somewhere. You have some endpoint that you talk to, whereas library is some package that you include in your own application. So it is not a separate service as such. You're just importing some package in your own code, and you're using whatever that package is offering. So the package will offer some methods to then talk to the library. Let me see if I have some slide on that. Yeah, so for example, here, like I had this for a different reason, but you can see here. So these are the different types that are supported by data types that are supported by Redis, right? So then you will have these commands like increment, decrement, etc. So this would be a part of the client that you are invoking, so that you can now do some operations on those particular data types that you're selecting. All right, so let's look at the requirements one by one. So our first one is our application layer. So what does the cache server need to do? The basic requirement was supporting that put and get functionality, right? So how would you do that if you're doing it locally? Obviously, you will just have a hash table. That is the most common data structure that one can use for caching, where you have O of 1 access to the value, given that you know the key. So you can have that in-memory hash table, but it can be at that simple, especially if you want to talk about some eviction policies, right? Because you can have the O of 1 access when you have your key. However, if their hash table, let's say, had only 10 entries in it, and if you wanted to store now 11th entry, how do you decide which entry to be deleted? Now, if the policy that you're using is least recently used, how would you know what entry was least recently used? Just by looking at the keys, you won't know that. You will need some additional information, and that's where the things can get a little more complicated on how you are managing that. And because, again, in this particular problem, there are not that many different components that the interviewer can discuss, it is likely that they will kind of ask you about, okay, talk about some eviction policy, what you're familiar with, or if you're suggesting that I will use LRU, then they would know that, or they would ask that, okay, then how are you implementing that? Like, they won't most likely, again, as I said, no coding, but at least some high level information about how you're organizing that data. So in terms of eviction policies, again, LRU is not the only one. It is one of the more popular ones, and the only policy that Memcache offers. However, Redis gives you an option of, let's see if we have that. Yeah, so Redis does offer you multiple different eviction policies, like no eviction, as we talked about, like nothing would be evicted. But it has LRU, it has least frequently used, it has random, I don't again know why would people randomly remove keys, but it supports that. And then, so there is a difference between all keys and volatile based on the cache expiry field, but pretty much again the same thing, least recently used based on either whether it has expiry or not. Again, volatile random, I don't know. I'm not particularly familiar with any use case where random could be useful, but the reason they are supporting mean that there could be some use cases. So these are again like something that Redis offers. Memcached does not offer any of these. They just has LRU and that's it. But it'll be nice to mention it to the interviewer what different eviction policies you are familiar with, and maybe also mention well, I won't call it pros and cons. It's more about applicability, right? Like depending on it, it will depend on your application, like what policy you need. It kind of, I think some policies, depending on your traffic pattern or the nature of your request, one policy might be better than the other. Cool. So let me just quickly look at the next slide. All right. So I've been talking for a long time. I need some volunteers to explain me how they would organize LRU. Actually, sorry, before that, looks like there is a question. Chai is asking, hi, eviction policy comes into picture on top of TTL, correct? Meaning that if cache is full, even after TTL, then eviction policy plays a role. Yes, that's right. All right. Ashok, do you want to talk about how would you implement LRU? Or do you have a question?
No, I just want to volunteer.
Sure.
So
thank you.
So one thing which comes to my mind is we definitely need to add the timestamp fields when these entries were populated, and then
per entry.
Yeah, per entry.
Okay.
And then some kind of batch jobs which will routinely go through the data structure and empty those who have whose time has elapsed. That's, I mean, I don't know, I mean, it's how efficient it is, but that's what comes to my mind.
So bad job going through and deleting those whose time has elapsed. So I got the part of timestamp.
Yeah.
But is that the timestamp for when it got inserted, or is it when it read, or are you updating it for on both?
Yeah, it will be. It will be continue to be updated. But usually in the database design also you have two fields: date created and date updated. So that because LRU is based on the last access. So I would say, yeah, it will continue to be, it will continue to be updated as and when it is accessed.
Okay. And then, but a job, so is the job going to sort all the entries and see what is at the tail end and remove that? Like how will the job know what to evict?
There could be a index for the timestamp. Yeah, I understand the issue. I'm not sure how to resolve that.
Okay, that's fine.
Yeah, maybe there can be an index on time, or this job is a continuous process which continues to go through the entire data structure and does the cleanup like some kind of garbage collection or.
Okay, I mean, that is certainly possible, but let's see if there is any other better solution. Better meaning get more optimal or little faster solution. I see a few other hands. So Ashok, if you don't mind, I will give the mic to somebody else.
Sure.
All right, thank you. All right, I see quite a few have raised your hands. I'll try to give chance to people who have not either asked a question or spoken before. So please excuse me if I'm not letting you talk. It's nothing personal, just trying to encourage participation. Rashmi?
Yeah, so basically we can use linked list along with hash map to store the last recent access. So in the hash map, key will be the string which is basically your key. And then a value is going to be the node of the linked list.
So let's say if I have a linked list, and is it a single linked list, doubly linked list, or does it matter?
Doubly linked
Okay.
list.
Okay.
And we will move the node, like whenever we access, whenever value is read, we move it to the front. And
Okay.
And when we update, add new value, if it is going beyond our defined size, we delete the node from the tail. So we are definitely sure that we haven't accessed that node. Like it is not it is LRU, basically least recently used node.
Okay. And what are you storing in the node? Is it just the value or something else too?
Just the value.
Do you think that will be enough?
Okay, that's a very good question. We can store key, but I'm just thinking whether we really need to store the key as well. And the timestamp of use, not really needed. Yeah, I think value should be good enough, because since we
So
are maintaining, yeah, good.
let's talk about the last use case that you mentioned, that if we feel that okay, our linked list is more or already occupying all the space that we have, let's say if we could
Oh
only
yeah,
have
capacity,
500,
basically
right?
capacity.
So if you're
Yeah.
deleting from the from this, what will happen if you don't have the key?
Oh yeah.
You also need to delete it from the hash table, right?
Hash map as well. That's right. Absolutely right. Yeah. So
Right. So
we need to have key and value, both of them there.
yeah, either that, or you can just have a key here, and here you can have the reference to the node and value. Like I don't think there is any specific preference as such. So the point is you need to store the key somewhere in the linked list, and then the value anywhere where you can have the easy access to the key.
Right.
Cool. I think that's definitely what I had in my mind as well. Thank you, Rashmi. And sorry, others. Hopefully, I'll give everybody else some other. Like, if for other questions, I'll give somebody else chance as well. So this is pretty much what Rashmi explained. You can have a combination of doubly linked list and a hash table, or I think in Java you already have a structure like that called linked hash map, which is essentially, I think, what we drew here. For anybody in case that you didn't quite catch what we're doing, is basically we are having two different data structures. In the hash table for the O of one use case, where you want the instant access to the value, so that you need the hash table in the key value form. But as we discussed before, that how do we evict the data that was least recently used, or how would we maintain the least recently used portion of that? So for that, we are having a linked list, a doubly linked list, so that moving back and forth would be easy. In the head, near the head, it will be the most recently items, and near the tail, it will be least recently used items. Whenever we access any value, we can remove that component from the linked list wherever it was, and put it in the head, because now that becomes the most recently used item, so that we don't have to then maintain timestamps as such, because the nature of the linked list, if you are on every axis, if you're moving that node from wherever it was to the head, that is also O of one operation. You don't have to traverse the whole list, because you will have the access to head and tail. So that is the updating that linked list is also O of one. And then because we are storing the keys in the node, if we are deleting something from the tail, we can now also delete that from our hash table. Otherwise, there'll be inconsistency. If you only remove from the linked list, but if you don't delete from the hash table, then your hash table will have certain entries which are not supposed to be there. That is something that you evicted. You need to evict from both. So that is basically what this slide says, that the DLL nodes will have the key or the key and the value. Like we need to store the value somewhere. Either you store it in the hash table or you store it in the node. I don't think that matters that much, but the DLL will need the key to delete it from the hash table when on eviction. So on access, you can move the that particular node of the DLL to the head, because now that becomes the most recently used item. To evict, remove the key from the tail and then delete from the hash table, because you have the access to the key. The deletion on the from the hash table is also going to be O of 1. If you're updating any existing value, you update the value in the hash table, but you also then need to remove or move that from the wherever it was in the linked list and put it in the front, unless it was already in the front, of course. And then for adding a new key, you'll have to do something similar, that you add it to the hash table and then you add that entry in the linked list near the head, so that will be the most recently used item. Anusha is asking, can you elaborate a little more on persistence? Yes, Anusha, we will get to that. I think the next slide is on that, so hold on a little bit. Raju is asking. So Raju, I think you raised your hand. So do you want to just elaborate on how about a min heap based approach? So do you have a question or comment on that?
No, I had a comment. I mean, that's also an approach. But in this case, I was curious as to how it's a O of, it should be an O of n to traverse the linked list, right? Whether or O of n by 2.
No. So that's why in the value field of the hash table, it's not just the value. It is the access to the node, reference to the node and the value, or just the reference to the node. And if you're storing the value in the linked list node.
Oh, okay. It's not, I mean, the linked list is from the perspective of just moving from the head to the tail.
Right.
Okay. That's the only reason you make it a doubly linked list, but essentially every node of the linked list is accessible in a random way, right? Directly accessible.
Well, that is not the only reason I made it doubly linked list. Like when you're moving that node from anywhere in the middle to the head, you can't just move it. You'll have to point the nodes previous to the nodes next.
Yeah, I know.
Right. So that will become also easy if you have doubly linked list. You won't have to kind of maintain separate pointers to get to that, because if you're going to that node directly from the hash table, how would you know what is the previous one, right? If you had a singly linked list, you'll have to traverse all the way.
Okay. Yeah, but then what's the need for a tail of the linked list?
That's where you delete it from when you evict it.
Oh.
So let's say the linked list will be of a fixed size, and then you can evict from the tail, and then you can move the tail to the previous one.
Yeah, got it. Yep. Thanks.
And do you want to elaborate on your min heap based approach? Like what were
the min heap based approach, I think, would reduce the memory footprint, and I guess the insert every time you access it, it gets moved up to the top. And
so what does your structure look like? Like in your min heap, what is the node?
So the node is the key. The key, but it's organized by TTL, I guess, in some notion of least recently used.
So are you using only min heap, or are you using min heap instead of using a linked list?
Yeah, I'm actually using just the min heap actually.
But then how will you have O of 1 access for any key?
Yeah, it won't be O of 1. Yeah, but the least recently used ones will be at the top, so it won't be O of 1. Yeah, just a thought.
Right. Okay, yeah, but usually for hash table, like that's what, or rather for any fast access, that's what we need, right? Like we will need faster access to that particular.
Yeah, we're trading.
The key.
I mean, space wise, I think maybe it's double, but okay. Yeah, got it. Yeah, there is.
And also, I think Vincent was asking, how will TTL work? Like how will the node be evicted using this approach when TTL has expired?
Yeah, you have to go to the bottom of the tree and clean out the leaf nodes, I guess.
So you will have to, depending on, again, if you're maintaining a heap, then you will have to traverse the whole heap to see who got evicted. If you're the property of whether it is min or like the least or not, if that depending on the least recently accessed, then that is not coupled with TTL, right? TTL could be different. TTL could be some random 5 minutes, but then if you have accessed that immediately, then that doesn't become that becomes most recently used, not least recently used. Whereas in the hash table, you can have a TTL and an index, and then see that, or for TTL, you can have separate job and see, okay, go through that, and whichever that have kind of expired, then go and delete those.
Yeah, makes sense. Thank you.
Cool. Welcome. Okay. Okay, a few hands are up. Ashok is asking, can you explain access again? Ashok, I see your hand is up too. So what particular access are you referring to?
Yeah, I'm not very clear. I mean, and maybe it has been covered. I couldn't get it. So suppose you access a key, a random key is access, which is in the middle of which is in the hash table, and which is also there in the middle of the linked list.
Give me just 1 second. Let me just give you an example. Maybe that will be clear, right? So here, let's just assume that our keys are just numbers 1 to 10, whatever, right? So let's say we have only 3 here, and then we have these 3 items. So here I have 1 here, 2 here, 3 here. So this is my, sorry, this is head, not tail, and this is tail. So, okay, what is your question?
Question is, suppose we access 1. Then how
so what you do in that case?
Somebody asked, I mean, how we will go and access and remove, bring the 1 to the head. It will become O of n, right?
No, that's what I'm saying. So here the hash table value will not be just the value, right? So here, if let's say if the value is alphabets, right? Here, if the values are ABC, right? We are not storing only ABC. We are storing the reference to the node and the value. So here, with this reference, you can directly jump to this particular element here. And then once you have access to here, because it's a doubly linked list, you also have access to the previous and next, right? So, and you also have access to your head and tail. So if you have access to head, you can just move this. So head next, this, you basically make sure that this next is preserved. So this next becomes here, this previous becomes this, and this next becomes here. So your linked list gets rearranged as this.
Okay, so basically this entire data structure is for TTL, to manage the TTL.
No, not TTL. TTL is separate. Like TTL could be,
sorry, LRU. Okay.
Yeah, least recently used. So at the tail end of the linked list, it will be the least recently used items, because you're moving, whenever you use an item, you're moving it to the head.
Okay.
So that way, at the end, you'll have an item which was least recently used. Make sense?
Yeah, and as a new entry, and it will be a fixed size. As a new entry comes in, you will drop the oldest one. I mean,
if you don't have space. So yeah, if you say that, okay, I can only in this particular, you will know how much your every value approximate size is going to be. You can either do calculations based on the memory consumption or fixed number of items. Fixed number of items becomes a lot easier. You can say, okay, as long as I can only store 500 entries. So if I only have 400, then you just have to add. You don't have to evict anything. You just have to add in the in front of the head, but then size becomes 401. But if you have 500 items, then you delete the tail and add it to the head. That way you maintain the size to be 500.
Right. Thank you.
Welcome. Okay, looks like there are a few other hands that are up. So let's see what questions do you have. Sri?
Yeah, 2 questions. First one, in the key value in the hash map, the value is going to be like what are there going to be 2 columns for values, or in one single column will have kind of a doc format?
I mean, depending on, I don't think it matters, like how you need 2 values in there. Like you need the value itself and you need a reference to the node. That way you're avoiding going all the way from not just that, like because multiple different keys could have same value. So how would you ever know which node to go to, right? So whether you can store that as 1 column but store a tuple in that column, or whether you're having 2 columns, like I think it's implementation dependent. What you need is like 2 values in there.
Okay, and second question was for TTL. Could you run through how the job works on the same?
So TTL is very different. For TTL, you will need a separate process, right? To kind of either run every, I mean, that is one way. There could be some other ways also, but that could look at what was the timestamp of that, and then when that timestamp expires, go and delete it, then delete it from both hash table and the linked list. But this kind of the structure of having two has nothing to do with solving the TTL problem. We were solving here the least recently used problem. For TTL, you will need a different way of running some kind of background thread or process, well, not process, maybe a thread to delete the entries which are expired.
Thank you.
Welcome. Okay, Pramod, do you have a question?
Hey, Vinay, thank you for taking my question. My question is, so the value is and the hash table value is saved as combination of key value, right, in the value itself. But I am wanting to know how is that OS to one read from the W linked list. I get it that the movement is OS to one because I know where the head is and where the tail is. But how do I say for a linked list you have 10 items? How is that read OS to one?
So what you are storing in the value of the hash table is a tuple where one item is the value itself. The second one is a reference to the node in the linked list.
Okay, so you're gotcha. So you're saying the reference to the node in the linked list. Okay, not the key or anything. Gotcha.
Not
That makes
key.
sense.
Yeah,
yes.
Key is the key in the key format itself. And then, so either you do this, or here in the hash table's value, you can only store the reference to the node, and in the node you store key and value.
Gotcha.
I don't think that
so
it matters
because
where
of
you're
the
storing the
reference,
value.
you can directly go into the W list and get the actual value. So that's
exactly
like a single memory read.
Yes.
Makes sense.
Because of that. There. Yeah, sure. Sorry if I didn't explain that properly. So that having that reference takes care of O of one access to that node. And then why doubly linked list is because we are directly jumping to that node. Having a doubly linked list, meaning having access to the previous and next, will make even moving that to head O of one, because you are just now manipulating pointer. If that was not the case, then you would have to, for singly linked list, you have to traverse all the way till the one before of that and then move that. Then that won't be O of one.
Yeah, that makes sense. Yep, thanks.
Yep, no problem. All right. Oh, okay. Looks like there are more questions. Balaji, do you have a question?
Yeah, so for implementing TTL, do we have to store some sort of timestamp or in the...
Yeah. Sorry. Yes, we will also have to, if you are supporting TTL, we'll also have to store timestamp. But yeah, but as I said, like this particular data structure, like combination, that was not solving the TTL functionality. It was solving the LRU functionality. But yes, if your cache supports TTL, then you will have to store timestamp as well. Otherwise, there is no way to know when that entry needs to be deleted.
Thank you.
Welcome. Ashok, your hand is raised. Do you have another question?
Yeah. So one thing about removing the entry on TTL, who will how we are going to implement it?
That is a separate challenge, right? Like that, this particular structure is not going to help with that. You will have to have a separate thread running behind, which is monitoring, okay, what is the current time and which entries have crossed that particular time, whatever the TTL was, and then delete it from the hash table and from the linked list. Okay, so that, I mean, having a background job would be a logical, would be. So I will be. So depending on, again, so when I said thread, because like if you have one process and multiple threads, they all share the memory. So thread will have access to that. I don't know if the job is going to have, if you have a separate job, is that going to have access to the memory? But you can, as long as you give that functionality where the job can go and tell that, okay, remove these entries based on, okay, what the time is. There has to be something in that process which will accept that and then delete it from the hash table. Okay. Okay, thank you. Pramod asking, can we use ordinary dictionary? Or I think depending on the language, what your dictionary supports, mine assumption is that dictionary is just a regular hash table. So in that case, you again won't know what is least recently used. So that's why you'll need the combination or linked hash map. All right, let's move on. All right, so the other requirement was persistence. So we need to store the data, not just in memory, because if that machine crashes, then we want to retrieve that data. If this is a functionality that you want to support, then you usually have, again, you can have multiple options, but the two kind of most frequently used items or popular techniques are using append-only files or append-only logs. So what it's basically a file, and every time a new write comes, you are writing that in that file. And the reason it is append-only is because by that nature, what you're doing is you're not touching anything prior to that particular point of that file, meaning that your disk seeks are going to be pretty efficient. You don't have to move your whatever that is accessing that disk back and forth, and you can continuously only write from that point onwards, making it more efficient. And then you only need to persist the writes, because no matter how many times you're reading it, it's not going to change the value, right? Like what you're interested in for persistence is the state of that. Like just because you're reading it, that kind of, you're just reading the value, it's not really changing anything. So you can only persist the writes. But even in that, there are a couple of different techniques, like either write every single write, or similar to our write back cache, write back cache, like you can kind of have an internal buffer where you kind of pile up a few writes and then write every second or every few seconds. Now, again, pros and cons. If you're writing every single write, you're going to have latency added, because you, again, depending on how you're, like when you're returning the ACK to the user, if you wait until that particular entry is written in the file and then giving the ACK back, it's going to take some time. But if you're buffering it, you can give the ACK back immediately and then write the buffer, flush the buffer after a specific period or when the buffer is full. The problem with that is, the advantage of that is, again, you're not writing again and again to the disk, so kind of saving time. But the disadvantage is that if you have something in the buffer and before you write it to the disk, if your machine crashes, you're going to lose that. So if that is acceptable, then you can use that. If that is not acceptable, then you can write to the append-only the log every single write. That is one technique. The second technique is periodic snapshot. So instead of writing every single time to the log, you can fork up different process and then take a snapshot of that, basically the current state of memory, and then write it to the disk. So that way, because you have a separate process doing that, like your main process is still, it's not busy accepting either the updates or reads, but then the second process basically then can just run in the background and persist that data on the disk. The advantage of that is you're not writing every single write. You can tune it to say that, okay, write that every 10 minutes, 15 minutes, 1 hour, and that then the writes becomes efficient. The disadvantage is that, again, if you are before you write to the database, or sorry, not database, to the file, if your machine crashes, you lose that data. And another disadvantage could also be, like, if you don't have that many writes, if your cache is more read heavy, then taking this snapshot every few minutes is kind of pointless, right? Like, why, if you're only going to have 15-20 writes every 1 hour, why are you taking the whole? And if your whole cache is a few gigabytes, like just for those 10-15 writes, like why are you taking a snapshot of the entire cache? Like that's kind of pointless. In that case, writing after a few seconds or writing every single write would be better. So it all depends on how you want to use the cache and what are the characteristics of the traffic, how the cache is being used, what is more important. Is it, do you actually have to persist every single write, or could there be a small data where if that get lost, no big deal. I want persistence, but not necessarily beyond 1 second or whatever acceptable threshold. So again, trade-offs, discuss what is, you can say that, okay, we can support either of these. Like if you want to support this, we can do this way, or we can support both. So here, how do I have that persistence? Yeah, in Redis, they basically support both append-only file or snapshot, and they can also I don't actually know whether this is customizable or not, or you can just, these are some of the preset things. But the point is, Redis supports both. Doesn't mean that you have to support both. Memcached does not support any persistence at all. So depending on, you can discuss with the interviewer, do we need to do this? And then do we have to pick only one, or give both options? From the user perspective, obviously having more options is good. That just increases complexity of your system. But it's not that, like, obviously user is going to benefit. So my recommendation would be suggest providing both options, and then how will you achieve that? Basically what we just discussed, append only logs or taking the snapshot, and that should be sufficient. Anusha asking, so in memcached, if we lose cache, then we need to build it from scratch. Yes. Well, it depends. Like if you have that data replicated, actually no, you're right. We need to, because I don't think memcache also supports replication. All right. So that was mainly the functional requirements of we wanted to handle get and put, that we saw how we would do it with the hash table itself. But then to handle the eviction policy, we saw how the only hash table is not enough. We need to combine that with a doubly linked list, and then got the LRU policy as well. And then we talked about persistence. So now reason to scale, right? Like this is all good, but are we going to do it only for that one particular instance, or do we actually need multiple instances? So these are some of the reasons that we need to scale our systems. And here most of those apply, except for API parallelization. But again, that's a different story. So if you have a lot of data to be stored in cache, obviously one machine is not going to be enough. Throughput, if you have large amount of requests coming in, you will need multiple machines handling those requests, so that your one machine doesn't become bottleneck. Hotspot, same thing. If you're using sharding, you'll take care of that. And availability and geolocation is basically for any distributed system. I think those two are kind of yes. So these are basically the reasons why we need to scale. So just having one machine is not enough. We need to go the distributed way.
Want to become a software engineer at Google? You can, like thousands of our students. You just need to learn from those who've already cleared FANG interviews. At Interview Kickstart, our interview prep courses are developed and taught live by 150 plus instructors from Tier 1 companies like Google and Facebook. Our courses are tailored to help you crack software engineering domain interviews, including back-end, full stack, machine learning, embedded systems, data science, and more. To learn more, book your free webinar slot today